that area is 22 times 15, which equals 330 feet. So this inside area is 330 feet. Okay, now let's go ahead and draw our walkway, because we know there's a walkway going around it. There's a walkway going around it. And the width of this walkway is 3 feet. So that means from the edge to the center is going to be 3 feet. That means this width is 3 feet. That means from the bottom to the bottom of the walkway is 3 feet. And that means the left side is 3 feet. It is 3 feet everywhere. Alright, then it says it wants the area of the sidewalk. Well, I can't directly do the sidewalk, because all I know about the sidewalk is it's 3 feet, so I can't find this and add it. I guess we could, it'd be a lot of work. But rather than doing that, we're going to find our total area. We're going to find our total area, and then all we're going to do is we're going to subtract out the garden/pool. Because if I did that, all I'd have left is the walkway, right? Total area minus what's inside is going to give me what's left over here. So to figure out the total area, I need to have length times width. Well, I know the garden is 15 feet. But if I walk from here to here, I don't walk 15 feet. I first have to walk 3 feet, then 15 feet, and then 3 more feet. So maybe I'll draw that really quick. So we have to go 3 feet. Then we'd have to go that 15 feet. And then we'd have to go 3 feet more to get from edge to edge. So that total length is going to be 15 plus 6, which is going to be 21. We'll do the same thing here. I can walk 22 feet, but I have to walk 3 more and 3 more here. So it's 22, bless you, plus 6. 22 plus 6 is going to be 28. I hope you can see that. I just had to write pretty big so you can see it. Do we all get where the 21 and 28 came from? Don't even be slightly confused, because you already know either it's going to be on the test or it's in my bag of questions I'm thinking about putting on a test. Okay, so our total area, that total area is going to equal 21 times 28. And that comes out to 588. Okay, good. That's my total area. Remember that inside area is 330. So if I take the outside area minus the inside area, I'm left with the sidewalk. So that's going to be 588 minus the 330. And that's going to give me 258 is the sidewalk. And let's go ahead and call it feet squared, is just the sidewalk area. So total minus that inside garden area equals that sidewalk area. That's how much pavement I would need to actually pave it if I needed to. Which is probably good to know if I'm paving something around a garden or a pool. Right, what area I have, so I know how much concrete to buy.
Wait, so what is a pool garden?
It's a garden that turns into a pool at the end. No, I just missed, because the typical question for this one is either garden or a pool. And while I was typing it, I went between the two. At first I called it a garden, and I changed it to a pool here. That way, when you see a garden or a pool on the test or homework, you know what problem it is. All right. Questions on this? Knowing that I'm probably thinking about putting it on a test? Okay. Questions on the homework? None? Okay.
Oh.
I already said there's none.
Okay.
Why are the hands up? I already said there's none. Nicholas, what question do you have?
6.
6. All right, I'm going to try rifling through these because we're probably going to have a lot. So tell me if you don't understand it before I continue. All right, 6. Find the area of... I don't know. 3. All right, 3 is probably one of the harder ones. 3 and I forget. There's one that looks just like this one. Okay, so let's go ahead and label the information I know. I know that PR equals 15. So the length from P to R is going to be 15. The length from Q to T is 12. I'm just going to shade it in red so we can see what we're talking about. Q to T is 12. And then P to S, let's go ahead and put it in green so we have a different color. P to S is going to be 10. We need to find RQ. The big takeaway from RQ is a base. And we know the formula for area is half our base times our height. Well, that means if I write area equals half our base times our height, let's go ahead and just start that. So if I just do area equals half our base, which is QR, I don't know that, times our height of 10, I need to find the area or QR to solve this. Okay? So I'm missing 2 variables. So all I'm going to do is I'm going to take that triangle. I'm going to take that triangle that's right here, and I'm going to flip it. I'm going to flip it because now I can find the area because I have a base of 15 and a height of 12. So that's going to allow me to find that area of this triangle. So using that 15 and that 12, so we'll do base equals 15. The height for this one is going to equal 12. So the area of the actual triangle is going to equal half my base times my height, which is 6 times 15, 60, is going to equal 90. Now, does the area of the triangle change depending on which way I'm showing it to you? Is the area of this triangle changing at all? So this area must be the exact same thing as this area. Okay, so all you're going to do is you're going to take that 90. You're going to plug it into this equation where your base this time is QR and your height is 10. And you're going to be able to solve for QR. Alright, so you're going to have 90 equals half of QR times 10. Multiply both sides by 2, you have 180. Divide by 10, and you're going to see it's 18. Does that make sense? Does that make sense? Because I'm sure a lot of you had the same question. Are we all good on that? Okay, next question. Yeah. 8. So number 8 is looking for a ratio of the areas of QRT and QTS. So let's go ahead and just write what the areas are for both of those. So for QRT, it's going to be half our base, which is 12, times our height, which I don't know the answer to. So that's going to be 6H. QTS has a base of 18. Still don't know the height, so that's going to be half of our base of 18 times our height, which I don't know, which is going to be 9H. Well, a ratio is just a fraction. A fraction comparing those two things. So the ratio for this one is going to be 6H over 9H. Well, H over H is just 1. So we're left with 6 over 9, which we can simplify down to 2 over 3. Or you could have written it as 2 colon 3. So in fact, if our height is the exact same, the only thing that's changing is our base. We could have compared 12 to 18 right off the bat. We could have did 12 divided by 18, which does equal 2 over 3 as well, because it's the only thing that's changing between the two. All right, it's getting across the point that if my height is the same for two triangles, the only thing that changes in it is our bases, and you can come up with a ratio that way. Good? Yeah.
9. I got the 3 altitude, but I didn't get the other 2.
Okay, cool. So number 9 is a lot like number 3 in the fact that you have to think of being able to turn a triangle on its side. I'm going to go ahead and draw my height right here because we know we're going to need one. It says that we have side lengths 5, 5, and it says we have a base of 8. So that means this height, our altitude, is going to cut it in half because it's an isosceles triangle. That means we have a right triangle with one side's 4, one side's 5. We can either realize that it's a special triangle that goes 3, 4, 5, or you could have did h squared plus 4 squared equals 5 squared. Either way, you would have find out h equals 3. So h equals 3. What we need to gain from this, because we're going to go on to another triangles, I need to get the area of this. I need to know the area of this triangle because it's going to stay the same for all 3 of them. It's the only thing that stays consistent on all 3 of them. So our area for this guy is going to equal half our base times our height, which is 4 times 3, which equals 12. So that's the area here. Well, if I redraw this triangle, I'm going to leave it the exact same shape. We'll redraw it exactly the same. We'll just see that we're looking for a different altitude. So our length down here is still 8. This is still 5. This is still 5. I'm just going to change which altitude I'm looking for. So instead I'm going to look for this guy. That guy right there. Let's call it X, since I already used H. Well, we have to remember that our area stayed the same. Our area is the exact same for both triangles, and our equation for area stays the exact same too. It's area equals half our base times our height. The only thing I change now is my height and my base. My base is now 5. So if we plug it in the equation that area equals half of base times height, our equation for this one is our area is still 12. That equals half. My new base is 5. I don't know my height, so we changed it to x. Alright, so we multiplied both sides by 2. This would be 24. Divided by 5. You're going to see that x equals 24 divided by 5. And guess what? When I draw my other height, what is my base of my other height? It's going to be 5 as well, so it's going to be the exact same height. All right?
Okay.
Does that make sense?
Yeah.
Good, good. Yeah, yeah. 12C. Did you do 12B?
Yeah.
Did you get it right?
Yeah.
Then you should have got 12B. Because 12A says find the area of PSR, right?
Wait, yeah.
Yeah. So the area of that one's going to be half our base. Well, our base of this guy is 30. From S to R is 30. The height is going to be 16. Half of 16 is 8, so this is going to be 240, right? Well, if we look at find area of OSR, OSR is right here. And the thing that we have to remember is that this is a parallelogram, so these two things are congruent, these two things are congruent, and in fact, all 4 things are congruent. No, we don't jump to that. We got those 2 things that are congruent. So O right now is a midpoint. So this segment right here that connects our midpoint cuts our triangle right in half. So if the area of the big triangle is 240, the area of this segment is going to be 120. Which means OSP is the top half, which also has to be 120, because this is 120 plus 120 equals 240. So both of these should be 120. You sure?
Yeah.
Okay. Yeah. All right, 7a, we have an envelope, and we're supposed to find the area of the shaded area. So what we need to recognize is that we need to first find the big area, which would be 15 times 38. I'm sure you found that, right? And then we need to subtract out this triangle here. Well, if this is 15 and this is 8, that makes the height of that triangle. Let me just write that triangle down here, just so I can actually write inside of it and you can see it. The height of that triangle is going to be 15 minus that 8. So the height is going to be 7. And the base is going to be 38. So it's going to be half of 38 times 7 is going to get you the area of this little sliver.
Oh, I just stupidly forgot to have 38.
Yeah, that's okay. Next. Yeah.
7B.
7b. 7b, we're going to hold off on 7b because there's an easier way to get it today. All right, it's kind of like a challenge question that if you got it, awesome, but today we're going to do trapezoids. So the last thing I want you to do is do something weird when we could just use the trapezoid rule. Yeah.
Wait, let me find it real quick. Wait, get back to me.
Okay.
I forgot my question.
Rena? 5? Okay, the trick with 5 is you need to connect z to x. You need to connect the point z to x, which will now give you a base and a height of this triangle. So we're going to do half our base times our height, which equals 24. So the area of this whole triangle is now 24. Well, the area doesn't change depending on my base, so I'm just going to say 24 is going to equal this new base times our height of 4. Okay, so to solve for ax, we'd have 24 equals half of ax, because that's our base there, times our 4, which is our height, right? Our height is still 4. Good? Yep. So a lot of those are just find the area and apply it to a new base. Yep. 11. The base of a triangle is 1 centimeter longer than its altitude. If the area of the triangle is 210, how long is the altitude? This is all about writing things correctly. So the base of the triangle is 1 centimeter longer than its altitude. Well, remember your altitude is your height. So I'm just going to call it h for height. And my base is going to equal h plus 1. All right, because our base of our triangle is 1 centimeter longer than our altitude. Make it 1 centimeter longer. It's the same thing as this one up here, so let's do both kind of at the same time. This one says one diagonal is twice the length of the other. So we know rhombus has 2 diagonals, so I'll have diagonal 1, diagonal 2. I'm going to rewrite diagonal 2 as 2 times diagonal 1, because that is twice the length of the other. So I have 1, and the other one's twice the length, so I can rewrite it as 2 times d sub I. Coming back here to the number 11, it says that the area equals 210. So 210 is going to equal half our base times our height, so that means 210 is going to equal 1/2. Our base, we said, was h plus 1. Our height is h. And you're going to work down to, correct me if I'm wrong, but you should end up with h squared plus h minus 420, which you can break down to x minus 20, x plus 21. Does that all look right for people that did it? Okay. Good on that one?
No.
Oh, did I make a mistake somewhere?
What did you cut in half?
I didn't cut anything in half.
Oh, you just multiplied by 2, sorry.
Yeah, this is me skipping some steps. I hope to save time, but it's not saving time. I should have just did step by step. But yeah, I just multiply both sides by 2 to get 420. I distribute my h to give me h squared plus h, and I have to subtract 420 from both sides. This is work that you need to be able to do.
I got it.
My work is just setting it up. Same thing here. We now have the area of a rhombus is 100. And 100 equals half of diagonal 1 times diagonal 2, which I'm going to rewrite as 1/2 of diagonal 1. And I'm going to rewrite diagonal 2 as 2 times diagonal 1, which you should come up with diagonal 1 equals 10 when you do the rest of the work. All right, so it's all about rewriting these in these problems. Okay, other questions? Quick. We're good otherwise? Okay. If you're stuck with something else you're not sure, I will post the answer guide today to it. That shows you a little. It doesn't show the full steps. It just shows you, like I would probably some of these I just write d1 equals d2 equals d2 times d1. Okay, then let's go on to today's assignment or today's lesson, and it's going to be on trapezoids. And I know we've seen the area of trapezoids before. I just like to always tell you why it works. Because that way if you forget on a test, you can think back. Like with parallelogram, how we cut off that one end, put it in the other, and it turns into a rectangle. Well, that's why it's just base times height. A lot of us might remember that the area of the trapezoid is half of base 1 plus base 2 times the height, or half of height times base 1 plus base 2. But let's see why that is true. So we're going to look at a trapezoid here. We're going to look at a trapezoid, and in order for it to be a trapezoid, our bases need to be parallel. So when I talk about bases, it doesn't matter which direction, right? I can turn this direction like this, and you should still know your bases are your parallel ones. So if I'm talking about bases, it's always our parallel ones, no matter which way I have it turned. So right now we have it in the traditional shape, and we are going to say that our top base, or our shorter base, is going to be 2. Our longer base is going to be 6. And our height is going to be 3. Well, the first thing I'm going to note is maybe I could turn this into a rectangle and solve it that way. So if we add some additional information to this, if I do this, and this, we'll pretend like that actually is a rectangular shape, not that leaning kind of thing. The area of that would just be 6 times 3, or 3 times 6. So the area of what we just did was 3 times 6, but that's going to be too big. That's too big. I have all this extra area here. So if I just did 6 times 3, I would have had too much area. If I bought that much concrete, I would have extra stuff. Let's look at the smaller rectangle I could form. Let's do this in green. So the smaller rectangle I could form is this guy here. And I'm going to go ahead and color that in because that's actually area that we need to know. So the area of our smaller one would be 3 times 2. So 3 times 2 would be 2. That's too small. If I bought that much concrete for this plan, I would run out and I wouldn't have room to do these triangles. But if we look carefully, and we look at both of these things, these two triangles, this is actually half and half. So if you look at the one that's too big and the one that's too small, if we could just average those together, all right, if we could just find the average of those, we would get this other half here, and it'd be the perfect size. So what we're doing with trapezoids is we're taking that big rectangle and that small rectangle, we're just finding the average of the two, because one is too big, one is too small. Take the average, and it will be perfect. So the average, if we take the average, the average is perfect. Not too hot, not too cold, it's just perfect. The average would be the perfect size of that particular trapezoid. That is why trapezoid formula has that half built into it. Because to have an average, you add the two things together and you divide by 2. So if I wanted to take the average of these, and we're actually never going to calculate the area of this one, surprisingly enough. So our area is just going to equal our two things. So that'd be 3 times 6 plus 3 times 2. And we divide it by 2. So my too big plus my too small divided by 2 is the perfect size. It becomes our area. In more theoretical writing, that is going to be, well, 3 is my height. So it'd be height times base 1 plus height times base 2 divided by 2. So here I'm going to do concrete example. Down here I'll do the hypothetical if we don't actually know those values yet. All right, a way we could rewrite this is we could factor out that 3. So we could do 3 times base 1 plus, let's use the concrete. That'd be 3 times 6 plus 2 over 2. I'm still taking the average. I'm multiplying by the height. Well, in more symbolic terms, that would be height times base 1 plus base 2 over 2. The last way I'm going to rewrite that is I'm going to pull that 1/2 out front. So I could rewrite this as 1/2 times 3 times 6 plus 2, which would just be 1/2 our height times base 1 plus base 2. So in fact, every one of these formulas would get us the area of this trapezoid. And sometimes we're going to use different ones depending on, well, we only use 2 potential ones. So the area of a trapezoid, we generally see it in this form, or sometimes we see it with the H on the other end. So the official area of a trapezoid we usually go with is 1/2 times our height times our base 1 plus our base 2, or sometimes you'll see it as 1/2 base 1 plus base 2 times our height. Doesn't matter, it's multiplication, so you can do it whenever you want. But this is what it stems to. It's finding averages. That's the whole goal of this, is finding an average. That's why it works. Does our big rectangle plus our small rectangle divided by 2 gets us that perfect size. All right, that's where it comes from. That way, if you're on a test, it's possible that you could forget this formula but still get it right by remembering that it's the big plus the small divided by 2. That's why I like going through those 2 examples. All right, the next thing we're going to talk about is using medians. So you can actually use your median to come up with your area of your trapezoid. And how that's going to work is, let's first draw a median. So I'm going to draw a median right through here. And we're going to call this base 1, we'll call this base 2, and we'll go ahead and have an H2. So we'll just call this H. Who remembers the formula to get a median? So let's just put median, and that equals, who remembers the formula for a median? 2 people? 2 people? All right, Emily.
It's base 1 plus base 2
It's base 1 plus base 2 divided by 2. Well, if we look back at our drawing up here, I had base 1 plus base 2 divided by 2, didn't I? That was already our average. It already is an averaged number. So if we look here, that base 1 plus base 2 divided by 2, if I multiply that by h, I have my area, because all of these are area formulas. So since B1 plus B2 is already an average, our area would just equal our height times that average, times B1 plus B2 over 2. So area directly deals with our median in the fact that we can get area, so the area of a trapezoid in medians would just be h times our median. And that's important to know, because there can be problems that give you the area and the height, and you have to find the median. All right? So that's why this is key to know. We don't use it oftentimes to find the area, but it's oftentimes used to go backwards, where I give you the area and the height, and you have to find your median. Okay? Because that's the only way you're going to be able to find it, is to know that fact. All right, so the big two takeaways here is half of height times base 1 plus base 2 is our area, or we can do our height times our median equals our area. All right, let's kind of plug through these answers because we only have 9 minutes, so we're going to go as quickly as possible. We're going to find the area of an isosceles trapezoid with legs 5 and bases 6 and 10. So that means we have to do a drawing. We have to do a drawing of that trapezoid. And it's isosceles, so that means that our legs are the exact same size. Ooh, that's a terrible one, but we'll roll with it. So that means if one leg is 5, the other leg is 5 because it's isosceles. One base is 6. Let's make the shorter one 6. That one 10. Area equals height. We always have to have the height, so we have to go ahead and find the height. So what I'm going to do is I'm going to draw 2 heights in. I'll call that h, and we'll have that. And in fact, I'm going to move this 10 down just a little bit. So this full length is 10. And since this length is 6, right here, that makes this 2, and this guy 2 as well. Because they have to add up to 10, and they're equally partitioned because it is an isosceles trapezoid. So that means to find h, all we're going to do is we're going to say h squared plus 2 squared equals our hypotenuse squared. So it's 5 squared. So I'm just finding h because this is a right triangle. H squared plus 2 squared equals 5 squared. That's going to be h squared plus 4 equals 25. We're going to have h squared equals 25 minus 4, which is 21. I'm going to take the square root of both sides, and h equals square root of 21. Tell me if I'm going too fast, or I'm writing too fast, or I'm going through too fast. All right, so that gives me my h. And if we recall our formula, we have area equals half my height times base 1 plus base 2. Plug in the information we know. We have half of height. Height is square root of 21. Times b1 plus b2. b1 is 6. b2 is 10. So we have 6 plus 10. That's going to give me 1/2 square root of 21 times 16. I don't want to take half of 21, so let's take the half out of the 16, and we're left with 8 square root of 21. Because you do have the commutative property that says I can reorder all these multiplications. I can rewrite this as 1/2 times 16 times square root of 21, which would be 8 times square root of 21. All right, find the length of the median. Or find the area and the length of the median. Well, the median is going to be easy. So we're going to save that till the end. But we're going to find the area. Well, area equals half our height. Our height in this one is 5. Times base 1 plus base 2. Bless you. That's going to equal 10 times is 50. So you plug in a calculator. Or what I do in my head is I just do 13 times 7, 20. 20 divided by 2 is 10. 10 times 5 is 50. So that's my area. My median. There's two ways we could find our median. We're just going to stick with base 1 plus base 2 divided by 2. That equals 10. And just recall that 10 times our height should be our area. 10 times 5, that's 50. All right, we're flying through. Any questions so far? I'm not going too fast, am I, for anyone? I know we should have seen this before, but sometimes it gets stuck on stuff. All right, we're supposed to find the area and the length of the medians. Just remember, your base 1 and base 2 don't necessarily mean that this is my base 1 and my base 2. They have to be the parallel ones. So for this guy, I would turn it on the side. All right? So our parallel ones are 14 and 9. So I'm going to say my base 1 equals 14. My base 2 equals 9. This time I'm going to find the median first, and I'm going to use that to find my area. So our median equals 14 plus 9 divided by 2, which is 23 divided by 2. Maybe I'll draw that in there so we can kind of see what I'm talking about. That is our median length right there. 23 divided by 2. Well, area has two formulas. The other formula we can use is h times our median. Well, our height is 23. Not our height. Our height is going to be 12. Because if I turn it sideways, our height is 12, right? By base 1, base 2. Our height is 12. Our median was that 23 over 2. That's going to equal 12 divided by 2 is 6. 6 times 23 is 120 plus 18 is 138. All right, we can actually get through. Okay, the next one says find the area and length of the median. Let's find area first, and then we'll do the median. So area equals half our height times our base 1 plus base 2. So area equals, well, half of 6 is 3 times 13 plus 5 is going to be 18, which is going to equal 54. All right, median. Our median is just going to equal that 13. Actually, let's find median a different way. Now, let's just stick with it. You guys can figure that out. 13 plus 5 divided by 2 is 18. Divided by 2 is 9. So this median length right here is 9. Let's just double check. 9 times 6, that's 54. Yep. Area is 54. 9 times our height is 54, so that works. All right, you have homework. It's not so bad. It's just 1 through 12. Most of those are filling out a table, and the table just gives you values. It tells you like your height, and it gives you like your area, and you have to find your median. All right, everyone, have a lovely, lovely Thursday.